This is Algebra 2 on Monday, December 8th. We are currently on page 189, doing Chramer's rule. And today we're going to go over examples 1 and 2. And also, we warmed up with problem number 27 on page 186 using minors. Stormy, we thought it would be a genius idea to use Wiki6. That way you don't have to write all the matrix down. So when you come back, we'll try that. So right now we're looking on page 189 under the systems of two linear equations. We discovered that solving a system of equations such as 1.4x plus 3.8y equals 3.4 and 2.5x minus 1.7y equals 10.9 would be really difficult using substitution and elimination because they're not whole numbers. So we are able to use determinants, which we all know how to do, especially with 2 by 2 matrices, to figure out how to solve this system of equations. So if we have an equation ax plus by equals c and ax plus dy equals f, which is in the middle of page 189, we can use the coefficients a, b, c, d, f, and e to figure it out. Now we can do it the old-fashioned way, where we multiply by something and subtract or add the equation, or we can use this formula in the key concepts box on the page of 189. Okay, take a look, Jessica, see if you can find it, the key concepts box. So we have to talk about it. A, B, and E are coefficients of one equation, and C, D, and F are the coefficients of the second equation.
I just had it here.
You just plug these.
Oh, okay. This is going to be on the next page.
Yeah, probably on C.
Yeah, okay. C. Yeah. I see EB, or C, A, B.
Okay.
Example 1?
Nope. Too far.
Before, oh, jeez.
This is very end
Hang on.
189. This may be something all of you would like to write down in your notes, because I don't know about you. You want to memorize that to find y, you have to find the determinant of C, B, F, D over the determinant of A, B, C, D. That's how you find the x value.
Okay, I found it. Key concept.
Okay. So really, to find the value of your x-coordinate and to find the value of your y-coordinate, you just plug this stuff in. You need to use the determinants of two separate matrices and then divide. Okay. So for the x value, you need to use the E and F coefficients, and you need to use the coefficients of y, which are b and d. So, in this, saying it sounds like it's really confusing, but it is easier when you actually have to get a plug stuff in. So again, I encourage all of you to copy this down. For the x-coordinates, you find the minor of E, B, F, and D, and you divide it by the determinant of the 2 by 2 matrix A, B, C, D. Yep. That's how you find the x-coordinate. Again, it's the determinant of E, B, F, D, where E and F are the equals to the equation, B and D are the y coefficients, over the determinant of the 2 by 2 matrix A, B, C, D, which are all the coefficients of your given values. Okay, and notice that your denominator of your x and y coordinates are the determinant of A, B, C, D. The only thing that changes is for the y coordinate, you plug in AC instead of CD. Again, I'll stress this. Keep them in the order the book says, or you're going to get the wrong answer. Okay? So for the first x coordinate, your answers, your equals, EF come first. and then your x coordinate, or excuse me, repeat. What they're equal to comes first in the column, and then your column of your y coordinate. For the y value, the x coordinates come first, and then the answer in the next column. But hey, luckily it's all over A, B, C, D, because at least you can remember that much. And of course, why can't the determinant of A, B, C, D be 0? We'll practice, I promise. Why can't the determinant of A, B, C, D be 0?
I remember this.
Well,
can't be
what? Yeah, say it louder.
Can't be the denominator.
You're right, you can't have 0 in the denominator. What's 5 over 0? Can you have 5 dividing into nothing? No. So that's why the determinant of A, B, C, D cannot be 0. Okay. I know it doesn't help to stare at letters. So let's look at example 1. On the top of 190. Solving by, and I hope you wrote this down because you're not going to remember how to put them in. Hey, look. These equations are all in the right order, aren't they? Hooray. So who can tell me what A, B, E is? What's A? And B? And E. Okay, somebody else tell me what the others are. What's C? D? No. Yes. You have to include the negatives. -5, and what's F? Okay. Do you follow, Jessica?
Kind of, like, it's kind of hard to hear them.
Oh,
So,
okay. I'll repeat for you. Can you tell me what A, B, and E are in these equations, according to what you remember from the key concepts box?
Is it 5, 7, and 13?
That's right. And so, therefore, what's D, F, and, or excuse me, C, D, and F?
2, -5, and 13.
Perfect. All right. So now we got to find our x coordinates by plugging all this stuff in. So to find our x coordinates, what is our numerator matrix? Answers come first. By answers, I mean 13 in the first column. Hey, 13 and 13. Huh. How about that? Your first column of your numerator matrix should be 13 and 13 because the first column is EF. What should your second column be? Right, which is? She says BD. What is BD? Your
7.
right.
-5.
7 and -5. Those are your y coordinates. So a nice way to remember that is if you're finding the x coordinate, you use the answers and the coefficients of the y's, the opposite. So your matrix, therefore read in row by row form, is 13, 7, 13, -5. Everybody see where I got that?
Yeah.
Yeah, we're plugging. Now, the denominator is the easy one. It's A, B, C, D. A, B, C, D is just the coefficients of everything but the answers. Right? So what would it be? Now, it goes in order. A, B in the first row and C, D in the second row.
Oh, so 5.
Uh-huh.
Plus 7. 2.
Right. 5, 7, 2, -5. Okay. So let's do it. Let's do the numerator. What's the determinant of 13, 7, and 13, -5? Read in row order. Ew, what's 13 times negative 5?
13 times, what, -5?
Yep. Yeah. No. Yes. Yeah. I don't know. I can't do all that in my head. It hurts my brain. Okay. Negative 65 minus what? Ew, 7 times 13. Okay. So what's negative 65 minus 91? Right. We found the numerator. It's a negative 156. Okay. What's the determinant of 5, 7, 2, negative 5? And Jessica, you can follow in the book too. What do we multiply first?
Can you say that again?
What's the determinant of 5, 7, 2, negative 5? Which are all the coefficients of our given equation.
5, 2, second. Oh, hang on.
5, 7, 2, negative 5. 5, 7 in the first row, 2, negative 5 in the second row.
You would multiply 5 by negative 5.
Is?
And what?
What is that?
Because they're diagonal.
No. What is 5 times negative 5?
Oh. That would be probably negative 25.
Okay. And then what?
And then you would do 2 times 7, which is 14.
Okay. What do we do with negative 25 and 14?
You subtract 14 from negative 25.
Okay. What is that?
That would be, that'd be negative 39.
Okay. So now we have a numerator of 156, a negative 156, and a denominator of negative 39. So what is the x-coordinate of this solution? You can use a calculator. Or you can cheat, I guess.
Divided by negative 39. Is it going to be 4?
That's right. X equals 4. Huh. I like that, right? That wasn't too horrible. It's just knowing how to put this together, right?
Yeah.
Well, again, your numerator is the only thing that changes. So who can tell me what the numerator of our next matrix should be? And if you don't remember, go back and look the box. Or you can cheat that again.
I can find the box.
Because as long as you know the first equation contains coefficients a, b, and e, and the second equation contains coefficients c, d, and f. Weird. And there's other little tricks you can use. But I think we need to get used to it first. But hey, one thing you do know is once you find it for the x-coordinate, your denominator is not going to change, is it? You're going to have something over negative 39, aren't you? What is that something?
Mister, do you think by chance you can put more water in this?
What do you think, Josiah? The writing? This is why we spent all that time on it. On the determinant.
Oh, okay. So the just one Chramer tool. I wish I could put it in my head.
No.
Just wake me up.
And that's something you were doing like that.
Okay, so I'm trying to figure out what the will be.
Cool.
Why does Chramer get to make the rules? Okay, so
What do you think, Jessica?
I'm just trying to figure it out. I'm not really sure.
It's weird. I know. Do you know what should go
Yeah.
in the numerator matrix? That's what's important here for the y value.
5, 13, 2, 13, 5, 7, and 2. Solution. So what did they do? They did pretty much the same. No, wait. Okay.
What helps me is that in the first one,
What?
in the x coordinate that we did, that was 4, your y coefficients go in. So therefore, in the second coordinate, the y coordinate that we're looking through now, your x coefficients go in. It's just figuring out which way they go.
Yeah, I guess.
So the first one had E, F, and then the x coefficients. This one has the y's in the column and then the answers, as in the things that they're equal to, in this case 13.
Yeah. Okay, so let's see. 5 times 13 minus 2 times 13 plus 5 minus 2 times 7. It's like the
Because once you know the matrices, the calculations aren't anything new.
Yeah, that's true.
Yeah.
So, are we using the same, like, matrix?
No. And if you look at
Is
the
there-
example, it tells you y equals, okay, let me rephrase. You use the same denominator matrix, which was A, B, C, D.
Oh,
Your numerator matrix is going to change.
okay. The numerator matrix.
Mm-hmm.
It looks like almost, no? Oh, okay, hold on. So that's, okay. That'd be 5 times 13. And 2. So 5 times 13 equals 65. And then 13 times 2 is going to be 20. Right? Now we do 65 minus 27. And then it's going to be 39 over negative 36.
It's going to be what?
Hang on. I'm trying to see if I did this right.
Not 39 over.
Yeah.
What was the denominator of the other one?
Let me go read it again, because I lost it. Hang on. The denominator of the other one was negative 39.
That's right. You don't need to change it, right? Because it's the same denominator matrix, so you don't need to redo it. Why bother, right?
Yeah.
So it's 39
Yeah, that's what I was trying to do.
negative 39. What's that?
Negative 1.
Okay. So what's your solution set?
So y equals negative 1.
Right. So how do we write that in an ordered pair?
That would be 4, negative 1.
That's right. So again, just like finding the determinant This thing is another rule you have to follow. And in math we have lots of those, like the Pythagorean theorem, for instance. Y equals mx plus b. The quadratic formula, which you'll learn. So it's just plugging in the coefficients and finding the determinant. And dividing. That's it. It's not horrible, just different, right? But luckily you don't have to learn any new calculations. You all know how to find the determinant of a 2 by 2, and you know how to divide. The only errors I can foresee is accidentally plugging in the wrong numbers. So that's why I encourage you to write down what the numerator of the X matrix Chramer's rule thingy should be, and what the numerator of the Y coordinate numerator matrix should be. Because the denominator is the determinant of A, B, C, D. So once you find X, it's kind of not too bad to find Y, because you only need to find one more, right?
Yeah.
And this is useful because things get hairy. I mean, that was pretty straightforward, right? Not too horrible.
Yeah.
But when you're plugging in real-world problems, you have something like 58 million. It'd be a bit harder. Are you two still writing over here?
Wait.
Huh?
I'm writing more.
Oh, that's fine. I'm just wondering if we can move on or not. That's all.
Yeah.
Okay. We're not going to actually calculate example 2, but we should read through it to see why people use these things. Because you'll see why in a minute why I don't really want to actually calculate it.
Oh.
The book will do it for us.
Good. I was just double checking.
Yeah.
Electron. Who wants to go? It's kind of a long and weird paragraph. And Miss Chris, you can volunteer also if you want.
I would like to volunteer to read it.
Okay.
All right. Election.
How to fit electrons.
I know. And I know. Electrons. In the 2000 presidential election, George Bush received about 8,400,000 votes in California and Texas, while Al Gore received about 8,300,000 votes in those states. The graph shows the percent of the popular vote that each candidate received in those states.
Okay. And this was a really big election. I don't know if any of you remember it. You might have been a little too young. This was 14 years ago, and they had to do a recount.
Yes.
It was considering what happened afterward, our country going to war and stuff, it was very controversial. And I remember the day the World Trade Center went down, too.
No kidding.
I remember. So it's interesting that to you guys it's probably history. To me, it was part of my life.
Yep. I remember exactly where I was doing this one.
Me too.
Yep.
Me too. So, okay. They're in different colors, of course. Go figure.
For those that have us that see color.
Yeah. They all look the same. Bush looks the same as Gore to me. So, Miss Chris, you'll have to describe.
All right. In California, Bush is in blue. In California, he got 42%
Yep.
42% of the presidential
Electrons vote?
electron vote. And Gore got 53%. In Texas, Bush got 59% and Gore got 38%. Which is
That makes sense because he was from Texas. Okay.
anyhow.
So it wants us to write a system of equations for this. Now,
Oh no.
well, it's not too bad, right? How do you want to set them up? By, like, we have 2 presidents and 2 states and 2 total votes. I think it would make pretty darn good sense to keep each president his own equation. Don't you think?
Yeah.
Yeah. So this must be Bush. 4.2x plus 0.59y equals 8,400,000. This is why don't want to do systems of equations by elimination, right? Take forever. And so therefore, since he got 53% in California, 0.53x plus 0.38y equals 8,300,000 votes. All right. Ugly. All right, look at little step B. The book is going to use Chramer's rule to figure this out. Find the total number of popular votes each got in California and Texas. So again, X represents the number of votes they got in Texas and California, and Y represents the number of total votes they got in Texas. You see step B, Miss Jessica? We're just gonna follow. We're gonna follow it because I don't want to have to do all these on our own, right?
Yeah.
Okay, the answers go in the numerator matrix for the x coordinates. The answers, i.e. what things are equal to, go first. That's why we have in the first column 8 million blah blah and another 8,300,000. And since we're in x land, we put the y coefficients in the second column. So our y coefficients, again, are 0.59, 0.38. Okay? Answers first, and then the opposite coefficients of what you're working on. And of course, the denominator matrix is all the coefficients in order. So 0.42, 0.59, 0.53, and 0.38. And apparently, when you do all this nonsense, they make you look at the other page. That's ridiculous, okay? Apparently, they got a total, once they did all the subtracting and dividing, approximately equals 11,136,512.08. Can we have 0.08 of a vote? You think?
If you're related to George Bush.
But can we, though, literally? If somebody votes, are you ever going to get 0.08 of a vote? No. So that's why they're approximately equal. Now again, for the y coordinates for the Texas folks, first is the x coordinates in the column and then the answers. So 0.42, below it 0.53, and then again in the second column 8,400,000, and then below that 8,300,000. And again the same thing, A, B, C, D matrix. People actually do this, by the way. This is real. And apparently in Texas, Texas, they get 6,309,601.57 votes. So I guess what happens is when you're over, so when we round up at 0.08 or round down to a vote. We round up or down. We're at 0.08. If you wanted to round it to the nearest vote. You guys have to remember how to round.
You would round down with 0.8.
That's right. Right.
No, you round up.
No, you're right. 0.08, not 0.8, right? So round to the nearest.
Yeah, you'd round down.
Right. And so that's why the X's would be 11,136,512. But what about the Y votes? They end in 0.57. Will that go up or down?
Up.
Right. So you'd have 6,309,602. Yuck. Right? Yeah. So that's what happens in real life. Now, if you want to take a look at the key concepts box for me, and you'll understand why I'm not making you do this. Look where it says key concepts below where it says systems of 3 linear equations.
No.
You would have to find the determinant of 3 by 3 matrices. You would have to find the determinant of 6 of them. Now, if you were hating me at the beginning of the day, I don't think you should hate me anymore. Because I'm not going to make you do it. Okay?
It's more the book, not really you.
Yeah, I'm going to make you do it. It would have taken forever, and I don't think you'd learn anything. Does that make sense? The reason why I wanted
Yeah.
to do this Chramer's rule is because in math from now on, you will be given formulas to follow, and you will have to learn how to understand how to plug in stuff. Does that make sense? So
Yeah.
you're given that, and if you don't want to write it down in your notes, at least mark the key concepts page in your notes so you can go look at it. Not that one, the one for the 2x2. It's on page,
Okay.
189. Okay, that is important. Again, I encourage you to write it down because I might let you have that piece of paper on your test because I don't expect you to memorize everything in the whole world. So you might have to be able to keep a matrix cheat sheet for the exam that's going to come up. That will include how to rotate and how to flip. Because, like I said, I don't even have those memorized. Okay?
Systems of two. That's the one where it says determine. No, it's not that one. Key concept.
Key concepts at the very bottom of page 189.
Oh, at the bottom. Okay, I'm still at the beginning. Let's see. Very bottom.
So just do 12 through 15 for practice on this.
On page
192. 12 through
190. 12 through
on
15.
page 192. All right.
That's our.
That is your practice homework thingy.
Oh, good. It's right here. Rule for two variables.
So again, page 192, problems 12 through 15, and we'll go over them. I want to check your answers as you go. All right. I'm going to stop recording. Not pause recording like I did that one time.